Hello everybody, welcome to the machine shop. I'm not at home, I'm at the Zagray farm using the lathe here, and I'm working on a Christmas present. Hopefully it turns out well, we'll see. I like to pretend that I'm a half-decent machinist when I need to be. Anyway, what I'm going to try to make today is a drop spindle. For those of you that don't know, a drop spindle it's one of the many ways of spinning wool, raw wool, into yarn. And unlike a spinning wheel, it's a very small, compact, something you can almost fit in your hand, and I'm going to try to make one. This is one chunk of material I'm going to try to use. I believe it's a piece of stainless. It's about the right diameter for the flywheel portion of it. So I'm going to start by machining this to size and shape on our handy lathe, and then I'll work on the whatever you'd call it, the spindle or the shank of it. So let's get started. Oh, by the way, just obviously I have no plans. I'm working off of what's in my head. No dimensions, just kind of whatever happens to work. The only important dimensional things are going to be some threads that I'm going to cut. So if you're interested, follow along. And if you're a real machinist, you probably don't want to watch this. You'll probably cringe. But let's see if we can have some fun and make a half-decent Christmas present here. Alright, so I got this piece chucked up in the 3-jaw chuck. I'm just going to make a light pass on the face and on the OD just to clean it up and true it up. We're in the slowest possible feed. Now I'm going to turn the face, I'll just touch off on it. Move in a hair. So the next thing I'm going to do is drill a hole through the center and thread it. So I want to drill a 3/8 16 hole in there, or excuse me, I want to tap a 3/8 16 hole. That means I need a tap drill size of 5/16. So get out your calipers, start looking. Now here's a trick for you. When you go to tap the hole, don't bother, well, you're going to do it by hand, but don't just put this tap in a tap wrench and try to send it in. Most taps, you'll see, have a little center drilled on the end. So what you can do, in your tailstock, put in a center, and that aligns the ass end. Now you can bring the tailstock forward into the workpiece with the tap in there and give it some slight pressure. That pressure not only helps feed it in, but it will also center everything. You can use this same trick on a milling machine. Say you have a chuck in your spindle, you drilled a hole, now you want to tap that hole. Take your chuck out, put in a center of some sort, just a piece of metal with a point on it, and center your tap that way, and either just pull down on your quill or attach a weight onto here so it pulls down for you. Put a tap wrench on your tap and send it in. That way you're not weeble wobbling your tap as you're trying to start it. And I would imagine this isn't too dangerous using a wrench because you have the tap really well supported on either end. It's not like you're using a hand wrench, just an open end wrench on a tap on something in the vise. So I'm going to turn this with one hand and apply a little bit of pressure with the quill, or to the tailstock rather, with the other. Now the next step is to send a parting blade through and part off what will become the flywheel. Alright, so I got the tool clamped into the quick change dovetail. So now what I'm going to do is make sure this blade is perfectly perpendicular to the face of this piece. I'm going to try a lower speed. Let's see, let's try top lever right, front lever in the center. There we go. It'll be super tedious. Okay, so we're back at the home shop doing some more work on the flywheel portion of it, or the correct terminology for a drop spindle. This isn't a flywheel, it's a whirl. I'm going to call it a flywheel. Anyway, I decided to drill some weight reducing holes around it. So we're back on the lathe. I have all the holes drilled, but of course they need some cleaning up. There's a bunch of burrs off of here, and also I want to clean up the cut surface that was left by the parting tool. And also I cut this a little bit thick intentionally, and so I have material to work with, and it feels just a little bit too heavy. So I'm just going to reduce the thickness until it feels about right. And the way I'm going to do that, I have the fully threaded hole, and I'm going to put it into the 3-jaw chuck so the threaded rod is just about flush with the face here, and tighten it down. And with the rotation of the chuck, as I cut this, it should just go to tighten the flywheel onto the piece of threaded rod, so it shouldn't unspin itself or anything. And I just gave it a test run, and it seems to run pretty true, but that really doesn't matter because we're going to be making another cut anyway. And also and I'm going to do this to both sides, and then while it's all chucked up like this, I'm going to knock off both corners here, put a nice 45 on them. I shortened the piece of threaded rod I was using to a length that I thought was appropriate, and I just cut it with a hacksaw. So now I will face both ends so they're nice and flat, and on one end I'm going to put a small dimple in there with a center drill so I can support the end of it with a center in the tailstock, so I can turn this down and remove these threads. So I just have a nice smooth shank, but I will leave a few threads in the bottom, of course, to thread into the flywheel. Alright, so I got everything ready to go. This took a little bit of screwing around to get right, but I have a center. This is a dead center. A live center would have been better, but what's nice about this is that it's skinnier and it's going to stay out of the way a little bit more. Got that supporting the end of the shank. This is tightened in the chuck. I had to extend out my tool because I had clearance issues here, and if I tilted or rotated the quick change tool holder, if I rotated it, then this side of the tool holder would hit into the chuck. So I got all that straightened out, and then I have my travel stop set at the proper location. So this tool will stop right here, and I determined the length of the shank that I want to be cut smooth, and I just held my calipers up and lined up the cutting tool with the calipers. It's not a precise dimension. Nothing's a precise dimension, so I just eyeballed it, and at the extreme of the travel over here I spun the chuck and I made sure that nothing's going to hit. And so I'm going to make a couple passes now and take the threads off and make a nice smooth shank. So we got a nice smooth finish. Alright, well, I finished it up. Unfortunately, when I did the last couple steps, I had forgotten to bring my video camera with me, but you really didn't miss anything too exciting. All I did, I chucked up this piece in the lathe. I cut a small groove in there that you can wrap the yarn around, and that keeps it on the end here and keeps it from coming off. At the very end here, you might remember there was a hole that we used the live center in to support this as it was turned. I threaded that hole with a 1032 thread. I put in a screw, I tightened it, cut it off, and then turned it and filed it nice and smooth so it fills that hole in. I also could have just, cut it off and just rounded off the end, but I didn't want to make it any shorter. I don't know, maybe it would have been a little cleaner if I just cut it off. But anyway, it's done. And I made a special nut for the back here, so that way this is threaded, and the nut of course is threaded, and you jam the two together so nothing comes apart. I just used a regular nut. And the way I turned this, I took a piece of threaded rod, I took this nut, or just a regular hexagonal nut, I put two of them on that threaded rod, tightened them against each other, and put it into the chuck of the lathe the same way I chucked up this with a piece of threaded rod. And then I turned this nut down and I used a file to round it off, and then I shined it up with some emery cloth, and that was that. And then I assembled this all together as you see it. I chucked this up in the lathe, and there was extra threaded rod coming out here. I made it with extra so I could do this last operation. With it all assembled the way I wanted it, I cut off the extra, and then with it spinning in the lathe, I faced off that last piece of threaded rod and dressed it with a file, and then also followed that with emery cloth. I brought it home, took it apart, and you see I chamfered all these holes. I used a chamfer on both sides, just put the chamfer in a drill press, and I just held this by hand and shoved it up into the chamfering tool, or countersink I should say. And I followed that up with a little bit of hand deburring with a deburring tool, just to make sure all the last little bits and pieces of burrs were gone. I did not file it or sandpaper it or anything because I wanted to retain the machining marks, because I think it looks pretty nice that way. Then I cleaned everything with carburetor cleaner, cleaned the threads very well. I put red Loctite on it, on the threads, screwed everything together, gave it a little extra crank together with some pliers and a vise, so it's mechanically cranked together, and also the red Loctite is doing its thing. And that's that. I also turned this down thinner to reduce some weight, so I think it's fairly lightweight now considering that it's made out of steel. I don't know if it's still too heavy or whatever, but at least it looks cool. And hopefully it'll make a good Christmas present for the knitter and spinner in the family. So anyway, thanks for watching, and hope you enjoyed this. As always, come on back for more.